What if I told you that there's a single factory being planned right now that could produce more computing power than the entire United States combined, and then double it on top of that? What if I told you it's not TSMC building it? Not Samsung, not any of the names we've been told are running the chip world. What if the guy doing it is Elon Musk, the same person who's already making rockets, electric cars, and humanoid robots, and he's now coming for the semiconductor industry too? I know, it sounds like a fever dream, but this is actually happening right now in 2026, with real partners, real money, and real procurement happening as we speak. So today I'm breaking down everything we know about the Terafab, what it is, why it exists, who's building it, and whether this is genuinely the biggest American industrial project in a generation or just another Musk announcement that gets quickly shelved 2 years from now. Okay, first things first, what actually is Terafab? The name comes from tera as in terawatt, because the goal of this facility is to produce 1 full terawatt of computing capacity every single year. For context, the entire United States right now generates about half a terawatt of compute. So what Musk is describing is a single project that would double the whole country's AI computing output under one roof. Terafab is a joint venture between Tesla, SpaceX, and xAI. All three are Musk's companies, and all three are becoming more dependent on chips than the world genuinely cannot produce fast enough. The project was officially announced on March 21st, 2026 at a live event at the Seahome Power Plant in Austin, Texas. The initial prototype facility is planned for the Giga Texas campus in Austin, right next to where Tesla already manufactures vehicles. Musk actually first brought this up at Tesla's shareholder meeting back in November 2025. His argument was basically, we looked at the absolute base case chip supply scenario from all of our existing partners, which is TSMC, Samsung, Micron, and all of them at full capacity, and it still wouldn't be enough, not even remotely close. So when the market can't give you what you need, you stop waiting and build it yourself. The project price is somewhere between $20 and $25 billion, which puts it amongst the largest single industrial investments in US's entire history. Tesla has already confirmed its 2026 capital expenditures will exceed $25 billion total, covering Terafab alongside 6 new factories, robotaxi rollout, and Optimus production. That is a company betting on itself in a massive way. Now, here's the part that really got me when I started digging around this. Musk said that the announcement that the current global chip fabrication facilities produce only about 2% of what Tesla and SpaceX will need across all their projects. 2%. That's not a supply chain headache, that's an existential problem. Think about what Tesla is actually trying to build out. They're looking at producing Optimus humanoid robots at a massive scale, potentially millions of units in a couple of years. Every single one of those robots needs edge-inference chips, meaning chips that run AI models locally on the device in real time without needing to ping a cloud server. Then you add self-driving vehicles. Then xAI's data infrastructure, then SpaceX's orbital plans. All of it runs on chips, enormous quantities of chips. Musk summed it up perfectly at the announcement. We either build the Terafab or we don't have the chips, and we need the chips, so we're going to build the Terafab. There's really no way to argue with that. It's blunt, it's direct, and it's correct. Now, this is where Terafab gets genuinely interesting because it's not one chip factory, it's actually 2 built within the same complex, each targeting a completely different product. The first factory produces what are called edge-inference chips. These go inside Tesla vehicles, inside Optimus robots, inside any device that needs to run AI without a data center in the background. The star product here is Tesla's 5th generation AI chip, the AI5. Tape out on AI5 has already been completed ahead of schedule, which is a big deal. especially for Musk. Now, he said that his team worked every single weekend for 6 months straight, holidays included, to hit that milestone. He went on to call AI5 likely the best edge-running inference chip currently available in terms of price-performance ratio. That is a serious claim, and I genuinely respect that he made it publicly. The second factory is where this whole thing goes full science fiction. Those chips are built specifically for space, not for Earth-based data centers, for orbital data centers. SpaceX's long-term roadmap involves launching AI infrastructure directly into orbit, and the chips needed for that have to survive radiation, extreme temperatures, and the physical reality of operating in space. According to the projections, up to 83% of Terafab's eventual output could be these non-terrestrial chips. I'll be honest, when I first read that number, I had to reread it twice. The full-scale facility could reach up to 100 million square feet, which would make it larger than everything else currently on the Giga Texas campus put together. We're talking about a completely different category of manufacturing than anything that exists anywhere in the world today. Now, let's talk about the partner that really makes this whole story land. On April 7th, 2026, Intel officially announced it was joining Terafab. Then, 2 weeks later, on April 23rd, Musk confirmed on Tesla's Q1 earnings call that the Terafab will be built using Intel's 14 angstrom manufacturing process, the most advanced node Intel has, and the one that isn't even fully in production yet. This is an enormous deal for Intel, like potentially company-defying enormous. Intel's CEO had previously said outright that if the company couldn't secure an external customer for the 14A process, it might exit the chip manufacturing business entirely. Then Musk walks in and hands them exactly what they needed. Tesla becomes Intel's first significant external customer for 14A, jumping ahead of Apple, Nvidia, Google, and AMD, who were all expected to evaluate it later this year. Musk's reasoning for choosing 14A is actually pretty logical. By the time Terafab scales up to real production volume, 14A should be mature and fully ready. Right now it's still being dialed in, but the timing tracks. Intel's 14A is built on ribbon-fed transistor architecture with backside power delivery, and it's genuinely one of the most advanced chip processes anywhere on the planet. Analyst Ben Badgerin at Creative Strategies said Musk's endorsement could end up being a bigger deal for Intel than most people initially assumed, and I think he's right. As of right now, only 3 companies in the world manufacture sub-5 nanometer chips at scale: TSMC, Samsung, and Intel. Musk is betting on the underdog of that group, and as someone who's followed this space for a while, I actually think that is the right call. Intel is hungry. They have something to prove, and now they have a real reason to make 14A work faster than anyone expected. Now, here's something worth understanding about how this actually plays out in practice, because Terafab is not going to materialize overnight. The first concrete step is a $3 billion research and development fabrication facility being built on the Giga Texas campus. Musk describes it as a place to try out ideas. It'll be capable of producing a few thousand wafer starts per month, and it's designed specifically for fast iteration. You make a chip, you test it, you revise the mask, and you do it again, all without ever shipping wafers to a separate facility. That kind of fully integrated loop does not currently exist anywhere in the world. Small batch AI5 production is expected to start in 2026, with volume production targeted for 2027. The larger scale Terafab aimed for 100,000 wafer starts per month and eventually scaling towards 1 million will be led in its early phase by SpaceX. The final location for the full facility hasn't been decided yet, but Musk was straightforward about it on the earnings call. Tesla does the R&D fab, SpaceX does the initial part of the larger scale Terafab, and then we've got to figure out the rest. Is this plan fully locked in? No, but nothing Elon does is, and the pace of movement is real. Teams are already reaching out to equipment suppliers including Applied Materials, Tokyo Electron, Lam Research, and Samsung, getting quotes and asking about delivery timelines. This went from public announcement to active procurement in a matter of weeks, and that kind of speed tells you this isn't just a concept. Now, look, I get what some of you might be thinking right now. Musk has announced big things before. Timelines slip. The original Cybertruck date, robotaxi, full self-driving next year. The list is, well, it's long. That skepticism is reasonable, and I won't talk you out of it, but here's why I see Terafab differently. The chip shortage is not a made-up problem. The fact that most of the world's advanced chip supply runs through a single company on an island that is one of the most geopolitically unstable regions on the planet is something the US government, the Pentagon, and every major tech company is quietly freaking out about. Musk isn't doing this because it's a cool project. He's doing it because every single thing his companies are building needs chips that he cannot reliably get in the quantities he'll need. This is infrastructure for survival, not ambition. And the partners here are not symbolic. Intel joining Terafab is not a press release move. The fact that procurement teams are already calling up Applied Materials and Tokyo Electron within weeks of the announcement show genuine operational intent. The $3 billion R&D fab is being built at the real site with a real timeline. That's not nothing. In my opinion, this is the most significant manufacturing project announced in the United States in the last decade, at minimum, and it goes well beyond just one company's ambitions. It's really a question of whether the US gets serious about owning its own chip future or keeps depending on partners that may not be always available. I think when you frame it that way, the answer becomes pretty obvious. So is all of this ambitious? Yeah, without question. Is it uncertain in some of its details? Still yes. But is it real and moving forward? More than ever before, and I genuinely believe that 10 years from now, we'll look back at March 2026 as the moment the whole thing started to shift.